So how do you balance chemical equation by algebraic process? You know that math stuff where, for example, they say A plus B equal to C, and they say A is equal to 2, and let's say B is equal to 1. So therefore, we easily know that C is equal to 2 plus 1, and we can get that C is equal to 3. That is how it's the same process here. Okay, when we get to add some variables and we get to find what those variables are and input them into the equation. So let's just work this particular one through. Okay, so now we place a coefficient for each of the parts of this equation. Okay, and we'll impute A here. Let's say this compound, the coefficient is A, and this is B, and this is C, and this is D. So these are the variables we are going to be looking for. Okay, and then the next thing is to bring out all the elements, all the atoms, the elements you can find in this equation. Now we can see carbon, and we can see hydrogen, and we can see oxygen. Okay, so the next step is to find how many, write out how many of mole of each of these elements you can see. Okay, now in this reactant, let's start from the beginning. We see that carbon has 3 subscripts and a coefficient, so we say 3a. Is there any other carbon in the reactant? No. And so let's go to the product. In the product, carbon has just a coefficient. There is no subscripts. So we say 3a equal to, this arrow sign now is what's equal to is now representing equal to C. Okay, we cannot just say 1C. 1 is just negligible, that's common math rule. And for hydrogen, let's go back now to the reactant. We have 8 subscripts and a coefficient for hydrogen. So we say 8a. There's no other hydrogen in the reactant. So let's check the product equal to, once you're going over to the product side, you make it equal to, okay? Equal to what hydrogen we have here. We have 2 subscripts and B coefficient. So we have 2D. Write the subscript first before the coefficient. Then for oxygen, we have 2 subscripts and B coefficient. So we say 2B equals, and in the reactant, we have 2 subscripts. In the product, we have 2 subscripts and C coefficient. So we have 2C plus, because we still have another oxygen here, plus D. Okay, so how do we solve this? We start by all this now. We'll start imputing this into this equation, into that equation, the way you do it in maths, to be able to find what A is, what B is, what C is, and what D is. Okay, so we first start by taking A to be 1. Okay, so that's just generally taking A to be 1. If we take A to be 1, how do we, what other unknown can we easily find from here? It's C. Okay, we can also even find B, but let's go with C because it's very much easier. Okay, so we know that C is equals to 3A, and we know that A is 1, so therefore C is equal to 3. A is equal to 1. And how about B? Okay, we can also find D. Okay, so we know 2D is equals to 8A, so 2D is equal to 8, and D is equal to 8 over 2, which is equal to 4. So we know that D is equal to 4. How about B? We can use this equation for oxygen, this, to find what B is. And when we do that, we have 2B equal to 2. We know C is already 3. So 2 times 3 plus, we know D is 4, plus 4. So 2B is equal to 6 plus 4, which is B now is 10 over 2, which is equal to 5. Okay, so now we've gotten what A is, what B is, what C is, and what D is. So therefore, balancing this equation, we have A is 1, so we don't have to write down the 1. Okay, B is 5, so we'll put down 5 here instead of B. And C is 3, so we'll put down the 3 here. And D is 4. So now the equation is balanced because now carbon has 3 in the reactant and 3 in the product. Hydrogen has 8 in the reactant and 8 in product. 4 times 2, 8. Oxygen has 10 in the reactant, 5 times 2, 10, and 10 in the product. 3 times 6 is 3 times 2 is 6, and 4. So 6 plus 4 is 10. So now we have a balanced equation. Okay. So let's do a second example. Okay, this is for sulfuric acid, sodium hydroxide. Okay, this is a neutralization reaction, and it is not balanced because in the reactant we can already see that hydrogen is 3, but in the product hydrogen is just 2. So that's just the most basic clue to tell us that this is not balanced, so we have to balance it. Okay, and if we use the variable method, we have, let's give this A. If we use the algebraic process, we have B, we have C, and we have D. Okay, so now the next thing that I said you should do is to bring out all the elements. There's hydrogen present here. There is sulfur. There's a way you can just, say SO4 instead, but let's just take it element by element. We can use just SO4 because SO4 is present in both the reactant and the product. But let's take it element by element. We have oxygen, we have sodium. No other element again, okay? So in the reactant, how many hydrogen do we have? Both subscript and coefficient. Okay, so we have 2A, 2A. No, then there's the hydrogen here in the sodium hydroxide. Okay, so plus B equals, is there hydrogen in the product? Yes, 2D. 2D. This is the equation for the hydrogen. Now, the equation for the sulfur. Sulfur is just A in the reactant and C in the product. How about oxygen? Oxygen in the reactant is 4A plus B equals 4C plus D. And lastly, sodium. Sodium in the reactant is just B. And in the product, we have 2C. Okay, so once again, let's assume A, or let's give it, let's give that A is equal to 1. Okay, so we've already gotten what A is. And then what other unknown can we get easily from here? C. Because if A is equal to 1, okay, C is equal to 1 as well. Because C is equal to A, so C is equal to 1. So we've easily gotten A and C. Okay, now what next? What other one can we easily get from here? B. We can use the sodium equation to get B. Okay, so B is equal to 2C, and we know that C is equal to 1, so B is equal to 2, because 2 times 1 is 2. And then lastly, the D. Okay, so we can use either the hydrogen equation or the hydrogen equation or the oxygen equation to solve for D. Whichever one we use, we're going to get the same answer. Okay, so let's just use the hydrogen. Okay, and in the hydrogen we have 2 times A, which is 2 times 1, plus 2 equal to 2D is the D that we are looking for. Let me just remove this here so that it does not confuse you. And from here we have 2 times 1 is 2 plus 2 equal to 2D. So 4 equal to 2D, and D is equal to 2. So our balanced equation is going to be H2SO4 plus B is 2, so 2 sodium hydroxide, okay, to give you C is 1, so we just write this just the way it is there, plus D is 2 molecule of H2O. Okay, so this is our balanced equation. Now you can see that hydrogen at the left is the same with hydrogen at the right. Sulfur at the left is the same with sulfur at the right. Oxygen at the left is the same with oxygen at the right, and sodium at the left is the same with sodium at the right. Okay, so what this algebraic process helps you to do is to quite easily balance more complex reactions, the ones that are more complex than just simple A plus B equal to C, or something as simple as OH plus oxygen equals to plus hydrogen equals to H2, so it helps you to like go further. I hope you understand. Any question, you send me a message.